Oh, great, welcome. So with this question, we're going to do an example, a utility maximization example, but with perfect complements, and then there's going to be a price change. So this is taken from Krugman Wells, Microeconomics, 2nd edition, Chapter 11, which is the Consumer Preferences and Consumer Choice chapter, question 15. So the question asked, for Crandall, cheese cubes and crackers are perfect complements. He wants to consume exactly one cheese cube with each cracker. Crandall has $2.40 to spend on cheese and crackers. One cheese cube costs 20 cents and one cracker costs 10 cents. Draw a diagram with crackers on the horizontal axis and cheese cubes on the vertical axis to answer the following questions. And the first question is, which bundle will Crandall consume? So it says draw it and figure that question out. So I was going to start drawing these myself like I do normally. However, it got a little tricky to get the units on the side exactly right. So I found this graph posted, I think, to like a Pepperdine website on Pepperdine. So hopefully we could use it to get the answer. So you got quantity of cheese cubes on the vertical axis and then quantity of crackers on the horizontal axis. So the first thing is the budget constraint. So we're told that we got a total income or total budget of $2.40. Cheese cubes cost 20 cents. So if Crandall were to spend all of his money, $2.40, on cheese cubes, and each cheese cube cost him 20 cents, he'd be able to buy a maximum of 12 cheese cubes. So that's 0 crackers and a maximum of 12 cheese cubes to satisfy this whole budget here. So that's this intersection over here. And then the budget line is defined by this intersection over here. So if Crandall were to spend $0 on cheese cubes and all of his money, $2.40 on crackers, and then crackers cost 10 cents each, then Crandall would be able to buy 24 crackers. So the budget line, our first budget line, is going to be defined by this point over here. And now for the indifference curve. So in this graph here, you could think of there's an infinite number of indifference curves. So we're told also that these cheese cubes and crackers are perfect complements such that, when Crandall wants one cheese cube, he needs to match that exactly with one cracker. So perfect complements mean that, let's say this person has over here 14 cheese cubes, but only 8 crackers. The additional cheese cubes this person has, anything past 8, don't improve this person's utility at all. So if there's only 8 crackers, then the utility that they get with 8 cheese cubes is exactly the same as the utility with 8 crackers and 10 cheese cubes, 8 crackers and 12 cheese cubes, 8 crackers and 14 cheese cubes. All those extra cheese cubes beyond 8 are complete use to them because each cheese cube needs to be matched with exactly one cracker. So that's a perfect complement. And then similarly along this indifference curve over this way, if the 8 cheese cubes are matched perfectly with the 8 crackers, let's say this person has 8 cheese cubes but 20 crackers, all of those additional crackers in excess of 8 don't improve this person's utility at all. Each additional one just keeps them on exactly the same total utility. So these right angle lines, these L-shaped indifference curves, are associated with perfect complements. So given that shape of the indifference curve, these like L-shaped indifference curves, the Crandall's going to maximize the utility such that where on this budget constraint they are, the spending that they spend on the budget constraint, that the number of cheese cubes is going to exactly match the number of crackers. So, there's this one-to-one complementary relationship between cheese cubes and crackers. So the point that Crandall's going to maximize their utility is the point where the number of cheese cubes perfectly matches the quantity of crackers. So, that's exactly this point A that we showed here with the indifference curve here and the budget line that we already set up already, BL1. You can think about another point over here. So let's say this person buys 10 crackers, and 10 crackers would be associated with, I think, 7 cheese cubes. That's a lower indifference. That's a lower utility for this person. Well, first off, remember that each cheese cube needs to be matched with exactly 1 cracker. So you got 7 cheese cubes that this person could spend, and they bought 10 crackers. However, they only need 7 crackers, so they're throwing away those 3 additional crackers associated with this lower utility. So the maximized utility at this point, where there's 8 cheese cubes purchased and 8 crackers purchased. Okay, so now we're told that the price of crackers rises 20 cents. So how many cheese cubes and how many crackers will Crandall consume now? So now we're going to reveal this new budget constraint. We're going to call it BL2. That's this point right here. So remember, Crandall has $2.40 to spend. So the quantity of cheese cubes, the price of cheese cubes hasn't changed at all. So the $2.40 is going to buy a maximum of 12 cheese cubes. And then the quantity of crackers, so each cracker costs 20 cents. So if we were to spend all of his money on crackers, he'd be able to buy 12 crackers. So this is our new budget line. Any point within this triangle, Crandall can afford. However, he wants to spend all of his money to maximize his utility. So he's going to spend somewhere along the budget line. All these points out in this big space out here would be a higher utility. However, Crandall simply can't afford any combination of cheese cubes and crackers out in this area over here. So to maximize his utility, he's going to purchase something along this budget line. And where is he going to purchase along that budget line? So these perfect complementary indifference curves, so the indifference curves are L-shaped because it's a perfect complement, make it actually really, really easy to figure out where he's going to make his purchase. Since each cheese cube needs to be matched 1 for 1 with a cracker, so it's the point that he's going to maximize his utility is going to be the point along this budget line where he spends as much money, spends money such that he purchases the same quantity of cheese cubes as crackers. So with $2.40, spending half of that, $1.20 on 6 cheese cubes, and then $1.20 on 6 crackers, he's going to buy this point here where he maximizes his income, or maximizes his utility. So now moving on to question C, part C. Show the income and substitution effects from the price rise. So if you recall, we moved from point A to point B here. So to think about the income and substitution effects, we want to start at point B here, and then do the following exercise, where at point B, we increase this person's income until they're on the same indifference curve that we started with. So if you remember, we were at point A to begin with. So we're going to increase the income such that they're on that back to that indifference curve. So that's this budget constraint budget line sub S, BL sub S right here. So normally with non-complementary indifference curves, if there's some kind of curvature, there would be point A, and then this BLS line would be tangent to the old indifference curve at some other point. And the difference between that original point, point A, and that other new point would reflect the substitution effect. However, because these are perfect complements, pushing back the budget line such that we are back on the old indifference curve takes us to exactly the same point that we were at before. So implying that there's no substitution effect, which makes quite a bit of sense since these are perfect complements, so there is no substitution to the price change. So the change, the next thing that we look at is where our new BLS line intersects the old indifference curve, where that point is, which is point A, to point B reflects the income effect. So the entire change in consumption in this case is due entirely to the income effect. So this is a very special case, with perfect complements, where given a change in price, the change in consumption is due entirely to the income effect. to see like the other types of effects that you might want to look at some of the other problems. Question 11 in this chapter is like a spam problem, and I think it talks about it pretty well. I'm going to try to do it next. So hopefully this was helpful. Let me know if you have any questions. Once again, this is a video that's a part of like a larger collection of problems and solutions to introductory microeconomics questions, and I'll give a link to the the group of questions in the video description. Thanks and have a good day. Bye.